Today we're going to do the 2-sample t-test. So you'll have two groups. It could be group A, group B, male or female. And so you're taking one set of you're measuring everything for people in group A. Could be people on this side of the room. And group B, people on that side of the room. People who are in the classroom versus people who are taking the class online. Two separate groups of people. And from that, we're going to need sample means for each group. I'll just call them A and B. We're going to need, of course, sample sizes for group A and group B. And we're going to need standard deviations for group A and group B. And we're also going to want to get the variances. So what if we're just given standard deviation, go ahead and square that. The reason for that, as you'll see in a minute, is that there are actually two different formulas for calculating the standard error when you have two means. One of them is called pooled, and the other is called unpooled. There is a specific hypothesis test we could use. We're going to use a rule of thumb. The rule of thumb has to do with these variances. If neither variance is twice the other, then we'll pool. That is, they're close enough. Neither is more than twice the other. If one of the variances, either one, is one of the variance is greater than or equal to 2 times the other, then we'll say they're far apart and we can't put them together. So what I would suggest is that whenever you're going to work one of these problems, that the first thing you do is pull all of this information out. If it's not already in a table, pull it out, make a table with that information, something like this. Then the next step would be to decide whether or not you're going to use the pooled or unpooled variance, or whether or not the pooled or unpooled. Let's go back to when we do a confidence interval, any confidence interval, it's the statistic plus or minus a confidence coefficient times standard error. So the statistic will always be x bar A minus x bar B, just the difference between the two sample means. Plus or minus a t, and let me say here with pooled, the degrees of freedom is equal to NA plus NB minus 2. It will be like NA minus 1 plus NB minus 1. So just add the sample sizes together, subtract 2. That's if you have a pooled. If you have unpooled, then it's a really nasty formula. So we're just going to use our calculator to get the degrees of freedom in this case. So we'll use the calculator. You can actually get numbers with decimals on this. You always want to round down. So if this came out to be 23.72, it's just we're going to use 23. Just drop whatever's in the decimal. Then times the standard error, and that's going to be one of two formulas. For pooled, it's going to be the square root of S squared A NA minus 1 plus this variance, these are variances, S squared A and B, NB minus 1 divided by NA plus NB minus 2. That's really the pooling of the variances. But remember, we're going to divide by the square root of n if we were doing variance. In this case, you multiply 1 over NA, there they are in the denominator, 1 over NB. Sorry, that's kind of running together there, but. And then if you have unpooled, it's just going to be the square root of S squared A over NA plus S squared B over NB. That's a lot to put up there, but that's, if you have this information and this down, this is sort of your intro / summary. If you get all this information down, then you've got the confidence interval. And of course, the hypothesis test. Let's see if I can squeeze this in somewhere. Just trying to get it all on one sheet. Of course, you'll write this down a little further. Is going to be the statistic x bar A minus x bar B minus the hypothesized parameter, mu A minus mu B. So we're looking at the difference between means our parameter. And then I'll just put over standard error. One of these two formulas, either the pooled or the unpooled. You could use different numbers, but usually you're just looking to see if one is greater than the other, one is less than the other. We're talking about the population means, or if they're not equal. All of those mean that this mu A minus mu B hypothesized is going to be 0. All the time in here, all the time I've ever used it in practice, but you could get a problem. It doesn't have to be 0. We could say, do they differ by at least 10? But we will use 0 for that all the time in this class.